Hello, Martin.
Yeah, if you get the microphone, then...
Yeah, okay.
Try to get hold of the microphone and I try to listen to you and
Excellent.
find an answer.
Excellent. I have a quick question. How would you try and use some of those techniques on a system like, for instance, the Quipus system from that the Incas used, which is a system of knotted chords, for instance? Are there some techniques that you can use to try and decipher that?
Yeah, well, well, it depends what you want to do. If you you can try to but the idea is that you work on already deciphered languages, and
okay.
I don't think that the Inca code of knots is deciphered, but I'm not a specialist on that. There's one interesting thing, and I thought I could have shown that to you, which concerns Inca. Inca use portraits, small portraits of people as signs for numbers.
Yeah, pictograms.
Pictograms. And that is quite interesting. And, well, with numbers, it's a smaller set, and they combine in a certain way, and you can figure out how it works rather easily. Yeah. So, but you know, that is numbers and not
the quick
words.
Thought, the quick thought that I had was that Quechua, the spoken language, has been transcribed into the Roman character set. And by doing frequency analysis between the Quipus and the Quechua, a known Quechua text or oral legend, and you assume that the word frequency is about the same, you might be able to do some sort of comparative analysis.
Oh yeah, that sounds interesting. Yeah. Mm-hmm.
You know, so there's a PhD for you.
This is well known, so that is not a problem. Yeah, it's a good idea. I would do that. Yeah.
Okay, I'll let you know how it works out. So my question refers to your part about.
Other questions?
Yeah. Is it working? Yeah. So. About this compression method thing.
I can't hear you.
Is it working? Yeah. No?
Yeah.
Well, about this compression method thing.
Yeah.
If I got it right, you can use it for comparing text types as well as identifying the language.
It works for both.
Yeah. Which means that that the text type influences the output. If so. This also implies that we need to know the kind of text type in order to identify the language, which seems to be kind of a circle, because usually we would expect to know the language in order to identify the text type. I mean, of course, if we receive an email, we know text type email, but if we have a book, we don't know if it's about computers, about a novel or whatever. So how to solve this kind of vicious circle thing?
Yeah. Yeah, that is a problem. Actually, the text type thing turned up when I experimented with the approach myself, and the problem is that, for example, in French emails, French emails are so different from written French texts because, well, first of all, there's the problem of character encoding with accented letters and so on. That is really, well, the difference was very big. But I would say that in general, if you don't know anything about the language and want to identify it with this method, you get very close, because at least the French emails I worked with came within the range of Romance languages. So the mix-up was between Spanish and French and so on. So, you know, there's always a language family thing. So you get quite close. For language identification, the difference between the different texts are sort of a nuisance, you know, but which is not too harmful. So you still get a good idea what language the text is in. And then I got to the idea that one can use the same method for the identification of text source. That's not in the literature. So in the literature, you only read that if the text comes from a very different source, there may be difficulties. And then I thought, well, it's a good idea to use it for text source. That is the reason why I think that the idea is original enough to get a software patent on
it. You showed in your lecture that there are already some programs or code to distinguish the language that is a text in, but is there already an implementation for the second part of your lecture?
No.
For determining that, or do you plan something like that, or does somebody plan something like that?
As far as I know, there's no implementation for the second part. At least, well, there can be some implementation, but I don't know that. I guess that Google has something like that because they must know what language somebody is interested in. So why could they know that I was interested in Samoan at some point? There must be something like that. But I don't really know that there is, I don't really know a computer implementation of the second part. The second part is, let's say, what linguists do when they look at texts. They look at numbers, typographically interesting words and so on, and then they try to make a guess. We did that in Cologne when I studied linguistics there. We had a course on Guarani, and there was no material on Guarani, and we had to find out something about Guarani, and we had a Guarani speaker who came once a week, so we prepared our transcriptions, and then we tried to find out things with him, and yeah, of course that was exactly that way that I showed to you, but I don't know of any implementation.
There is a hint if you are looking at HTML. Oh, I'm sorry.
Yeah.
Did I interrupt you?
No, I just thought of the second part. Perhaps I will do a project on that, and perhaps I will try to find to work on an implementation. But I don't know yet. So,
if you're looking at HTML text, it's a good hint to look at the source code. Just in the beginning, in good HTML, there is a language code, and sometimes it's true.
Yeah, that's right. That's right.
Also, it's a good hint to learn foreign scripts.
Mm-hmm.
I read Cyrillic script pretty well, and I could very well identify words that help to identify language in all Cyrillic script languages which I found, which is pretty many. Mm-hmm. I always stumble about dates, apparent dates, which I can't read because they are in some index scripts, and I'm going to learn that.
Mm-hmm. Yeah. Mm-hmm.
About this compression thing, since since compression reduces redundancy or removes redundancy from data, does that say anything about the redundancy in languages? Because since language has a lot of redundancy, so we can understand each other.
Yeah. Yeah, of course. There is lots of redundancies, and one can reduce that. Actually, redundancy is sort of a problem with this approach, I prepared another text of this kind that came from Basque, and then I thought it was not a good idea to show that because due to redundancies, some verb forms are so long that you think that they are content words. And well, you realize that when you put it into your favorite search engine, but you know, it shows that life is not so easy. You know, that yeah.
Okay.
But of course, redundancies are in every language, and they are useful for communication. They are not so useful if you really want to strip everything off and only have the direct access to information, of course.
Yeah, but what I meant was is the compression rate. Let's say in German maybe it's 43%, and in Italian it's 75%. Can you say that Italian has more redundancies in it than German or something?
You can't say that. No. That's not measurable.
Okay, that was my question.
Okay, hi Martin, I'm over here.
Hi.
You were talking, the languages you've been talking about are ones that you already have that you can sort of read in front of you. What if you had a digital text that you, a digital file that you assume is a text, but you don't know the coding for it?
Yeah.
You don't know whether it's in any of the Unicode whatever things. Do you just try through all the different ones? Because you can get interesting things in Chinese and Devangali and whatever. Do you know of any way of going about with that?
Yeah, I would try the compression approach for that, because with the compression approach, you don't really have to know how to read the text. You know, if in your database there is a text which it has to be in the same compression, in the same encoding, of course, then you can match them. Because if there is no model in your database, you won't get a result. But that, I would try that, because for that approach, it's not even necessary that you read the text. That's why it's interesting for spam detection too, because you don't have to read the email messages. You just take them as randomly encoded texts and can compare them.
Just something that came to my mind to your compression method. I think the German police, or BKA, this could also be helpful to them, because after they searched for terrorists on Google, they could verify them using your compression method.
Yeah, of course they can, yeah. Mm-hmm. Of course, yeah. Well, I personally think that, well, let's say from our perspectives, the world is full of intelligence agencies and police departments that are using nifty methods to find terrorists. But I think people who really need such approaches, like, well, for example, the second part of my talk, other people, that want to, well, firms like Google that have to treat very many texts from very many different languages and have to know at least some, have to get at least some idea what these texts are about. So for them, that, well, this approach is interesting, and I would say that police and intelligence agencies are, well, can use these methods too and will use these methods too, but they aren't those who profit in the first place, and that aren't, well, well, I think they can rely on their traditional methods as well, and they will perhaps rely on these methods too. More questions?
Okay, sorry, I don't want to add any more questions. There are many things I think of what you now start.